Hello students, our topic is recording and reporting control charts and production control. Objectives are in this to know the complete idea about the production in food industries regarding production and its control. Increasing customer demand for safe food has led food industry to build up food safety and quality systems. The food safety and quality are affected by insufficiency on administration, supplier and production technologies, working environment, human resources and control activities. In all production processes, we need to monitor the extent to which our products meet specifications. In the most general terms, there are two enemies of product quality: deviations from target specifications, excessive variability around target specifications. Control charts. The control chart is a graph used to study how a process changes over time. Data are plotted in time order. A control chart always a central line for the average, an upper line for the upper control limit and a lower line for the lower control limit. These lines are determined from historical data. By comparing current data to these lines, you can draw conclusions about whether the process variation is constant, in control, or is unpredictable, that is out of control, affected by special causes of variation. Control charts for variable data are used in pairs. The top chart monitors the average or the cantering of the distribution data from the process. The bottom chart monitors the range or the width of the distribution. If your data were shots in target practice is average where the shots are clustering and the range is how tightly they are clustered. Control charts for attribute data are used singly. When to use a control chart? When controlling ongoing process by finding and correcting problems as they occur. When predicting the expected range of outcomes from a process. When determining whether a process is stable, that is in statistical control. When analyzing patterns of process variation from special causes, non-routine events or common causes, that is built into the process. When determining whether your quality improvement project should aim to prevent specific problems or to make fundamental changes to the process. Now we will see about the control chart basic procedure. Choose the appropriate control chart for your data. Determine the appropriate time period for collecting and plotting data. Collect data, construct your chart and analyze the data. Look for out of control signals on the control chart. When one is identified, mark it on the chart and investigate the cause. Document how you investigated, what you learned, the cause and how it was corrected. Out of control signals. A single point outside the control limits, that is in figure point 16 is above the UCL, that is upper control limit. Next one is 2 out of 3 successive points are on the same side of the central line and further than 2 sigma from it, that is 0.4 sends that signal. 4 out of 5 successive points are on the same side of the center line and further than 1 sigma from it. The same figure 0.11 sends that signal. A run of 8 in a row are on the same side of the central line, or 10 out of 11, 12 out of 14 or 16 out of 20. That is in the same figure you can see the 0.21 is 8 in a row above the central line. Obvious consist or persistent pattern that suggests something unusual about your data and your process. Now continue to plot data as they are generated. As each new data is plotted, check for new out of control signals. When you start a new control chart, the process may be out of control. If so, the control limits calculated from the first 20 points are conditional limits. When you have at least 20 sequential points from a period when the process is operating in control, recalculate control limits. Now we will see about the types of control charts. There are different types of control charts, and a control chart should be selected based on the data type, that is continuous or discrete. For continuous data, there are 3 control charts, and for discrete there are 4. So you can see the tabular column here. For continuous data, IMR, X bar R, X bar S, and for discrete C, U, P and NP. In continuous data, control chart is selected depending on the subgroup size. Here you can see the description and control chart. Sample is individual measurement and control chart is IMR, that is individual moving range. Next description is sample is subgroup averages with subgroup sizes, and control chart is X bar R, that is mean and range chart. Next description is sample is subgroup averages with subgroup sizes. Here control chart is X bar S, mean and standard deviation. In discrete data, control chart is selected depending upon the lot size and defect or defective. Here you can see the defects and defective. Constant lot size, defects are C and defectives is NP. Variable lot size, defects is U and defectives is P. Understanding control charts and its application in ITES industry. Now we can see about the example that is taken from multinational US bank. A project was done to reduce the cycle time of international wire transfer process from 4.76 days to 1 day. In this project, cross-functional teams across the globe were involved. In control phase of DMAC projects, control charts help to keep a watch on the improved metric, that is project Y or goal, and critical XS, which is impacting on project Y. Control charts recommended as a part of the control phase were cycle time of international wire transfers, that is in continuous data. Processing time of each operator on different wires, that is continuous data. Number of people absent on any given day, that is discrete data. Now we will see about the first chart, that is cycle time of international wire transfers continuous data. In this continuous data and subgroup sizes 1 IMR chart. These charts can also be used to compare the before and after state of the project merits also. So the chart on the top left is cycle time before improvements, and chart on the top right is cycle time after the improvements. The chart below includes individual moving range also. The aim of any Six Sigma project could be twofold. One is to reduce variation and 2 is to shift mean. Individual chart represents the cycle time of wire transfers, that is indicating the central value, that is mean of the data set, and the moving ranges representing the spread of the data variation. Movement of mean is quite evident, which 4.76 days to 0.97 days was. Spread of the data is also reduced from moving range of approximate 2 to 0.479. Next we will look after the chart, that is processing time of each operator on different wires. Here X bar R control chart is called mean and range chart. In this case, each operator, that is individual subgroup, was processing different number of bytes hourly. So, subgroup size will differ from one subgroup to other subgroup. Hence, the control limits are displayed like zigzag. Processing time of the agents is in control limits and range is also within control. Now, chart 3. Number of people absent on any given day, that is U chart. This graph represents the number of people absent on any given day. It shows 4 points outside the control limits. On further investigation, it was evident that there were two major festivals during that time. In order to handle the festive season correctly, a corrective action is recommended to be implemented going forward. So, control charts not only help you keep a bird eye view on the process health, but also it can help you improve it further. There are various tools which can help create a control chart. However, the most common tool used is Minitab. Further tutorials helps you to understand how to create a control chart in Minitab, that is IMR chart. In this, step 1 is Minitab path to start, and then control charts, variable chart for individuals, that is IMR. Step 2 is enter data, that is cycle time, in the variable column. Next, in the step 3, you have to click OK to get IMR chart. Now, uses of stages in control chart. Individual chart takes care of centering and moving range takes care of spread of the data. There are other interpretations that can be drawn with the help of control charts. For example, before project status and after project status can be represented on a same graph showing improvement in the metrics. Arrangement data in Minitab like shown below and follow the steps given below. As I told you earlier, step 1, that is select start, control chart, variable chart for individual, that is IMR. Before and after project data should be stacked in one column as shown in Minitab, output in column C1 and in C2. Add status which will have headers like before project cycle time and after project cycle time. In step 2, select cycle time in variables and then go to IMR options, that is go to stages tab and select status in that column. Now, in step 3, press OK to see the result. Takeaways from the graph. Individual chart shows before the project cycle time of transactions was 5 minutes and after the project it is 2.37 minutes. There is a reduction in the cycle time per transaction. Moving range chart shows that the variation of the data has reduced after the project. There are no special causes as well as in the process. Now, X bar R chart. In this, X bar chart is created when the subgroup size per subgroup is between 2 to 8. Subgroup size consider each agent as one subgroup and consider the number of cases picked for each agent is 5 per day. Then subgroup size becomes 5. There is a possibility that each subgroup could be having a varying subgroup size. Let us understand how we can create the X bar R chart for both of the instances. Now consider data given is for below Lean Six Sigma project cycle time of transactions and after the improvements are implemented, and column C3 contains information of agent who process these transactions. In this step 1, go to start, control, charts, variable charts for subgroup X bar R. In step 2, select before cycle time and agent in subgroup size as sample size per agent is varying in this case. Otherwise, mention 5 in the subgroup size. If 5 transactions each were picked for each associate. In step 3, click OK. Now, what you have to take away? Control chart X bar R is generated, and if you look at the control limits, they are varying because the subgroup size per subgroup, that is agents, is varying. Now, X bar R with constant subgroup size for all subgroups. Look at the control chart below. If subgroup size of 5 is entered in the subgroup size cell in Minitab, the control limits are in a straight line. Now, in the above control charts, X bar chart represents the variation in the center value and R chart represents the spread of the data points. Now, control chart as run chart. Interpretations which can be drawn from a run chart can also be depicted from a control chart. Run chart identified special causes in a data set by identifying clusters, oscillations, trends, etc. Same can be interpreted through control chart, and control charts provides information on special causes over and above run chart. Now you have to go to options in any of the control charts. Following could be seen under header tests. Select perform all tests for special causes. Now you can see the comparisons. Test for special causes like 9 points in a row on the same side of the center line, correspondence to clustering in a run chart. 6 points in a row all increasing or decreasing, correspondence to trends in a run chart. 14 points in a row alternating up and down, correspondence to oscillations in a run chart. There are 8 tests done for special causes in continuous data control charts and 4 tests done for discrete data control charts. Discrete data P chart. In here, fixed lot size, that is considered a situation when client said they will do quality check for 30 processed transactions, not concerned about the transaction processed by the team. Variable lot size. Customer will do quality check on the 3% of the transactions processed by the team on a daily basis. Now, when a team processes 1000 transactions, sample size would be 30, and when the team processes 1100 transactions, sample size will be 33, and hence the lot size will be varying. For a P chart, lot size is variable and customer is monitoring the process on defectives. Consider the below mentioned data for the chart. As I have told you in the earlier, now I have given the numbers for defectives and sample lot also. So here now after doing that one, in the step 1 start control chart, attribute charts, P chart. In step 2, in variables enter defectives and in subgroup size enter sample lot. In step 3, click OK to get the control chart. Control limits are varying because of varying sample lot. Now we will see about the recording and reporting in production. This unit covers the skills and knowledge required to record and report on the results of the inspection and testing activities according to defined operating procedures. It involves completing required quality control documentation accurately and in full and in making reports to the appropriate people in line with organization procedures. This will involve completing checklist and written documentation and in making verbal and written reports on the results of inspection and test activities. Your responsibilities will require you to comply with organization, policy and procedures for the activities undertaken, and report any problems with the activities that you cannot personally resolve or are outside your permitted authority to the appropriate people. You will be expected to work with minimum of supervision, taking personal responsibility for your actions and the quality and accuracy of the work that you carry out. Your underpinning knowledge will be sufficient to provide a sound basis for your work and to adopt an informed approach to recording and reporting the information accurately and legibly. You will understand the principles of inspection and testing and the importance of accurate, clear and complete records in order to provide a sound background for carrying out the activities. You will understand the safety precautions required when working within the manufacturing environment. You will be required to demonstrate safe working practices throughout. Will understand the responsibility you owe to yourself and others in the workplace. This unit on recording and reporting the results of inspection and testing involves mainly maintenance, accurate, clear and complete records, providing reports on inspection and test results in a timely fashion, reporting unsolvable problems or problems that you are not responsible for to the appropriate person, working in ways which maintain the safety of yourself and others. Performance criteria. Under this you have different performance criteria. First one is work safely at all times, complying with health and safety. Obtain and use the correct quality control documentation for the manufacturing method and product. Record the results of the inspection activities in the appropriate format. Record inspection and test results accurately and legibly. Record all required details of the inspection and test activities and results. Pass completed records on to the correct person or location. Provide required reports on time and through the correct channels of the communication. Now, to know the knowledge and understanding, what are the relevant health and safety requirements of the work area in which you are recording the results of inspection or testing activities. What are the specific safe working practices, sampling, collection, testing procedures and environmental regulations that need to be observed. Next one is how to obtain the necessary quality control documentation that is used. How to complete quality control documentation. Why it is important to complete documentation accurately and legibly. When quality control documentation should be completed. What information needs to be recorded in relation to the manufacturing method and sample type. What use is made of quality control documentation by the organization. Where or to whom you should pass on completed records. So, in this session, we all have learned about the important aspects and also specific to quality management in the food industry. Thank you, students.